All right, so this is 6.2 going through the answers there. So we have a small ferry runs every half hour from one side of the large river to the other. The number of cars X on a randomly chosen ferry trip has a probability distribution shown here with a mean of 3.87, a standard deviation of 1.29. The cost of the ferry trip is $5. Define M is the money collected on a randomly selected ferry trip. So this is where it's important for us to write our variables. I think it's important to say, hey, M is equal to 5 times X, where X is the number of cars, right? Because that's how much money we're going to make, right? If there's 0 cars, you'd make $0. If there's 3 cars, you'd make 15. So now it's really clear we are multiplying. Well, not how to spell multiplying. We are multiplying by a constant. So now when it says, what's the new standard deviation of M? Hey, standard deviations, they do just multiply normally. So I take my original 1.29 and I'm going to times that by 5 to get out 6.45. So my correct answer here is B. All right. Number 2, during the winter months, the temperatures on some Colorado cabin can stay well below freezing for weeks at a time. To prevent the pipes from freezing, Miss Starnes sets the thermostat to 50 degrees Fahrenheit. She also buys a digital thermometer that records the indoor temperature each night at midnight. Unfortunately, the thermometer is programmed to measure the temperature in degrees Celsius. Based on several years worth of data, the temperature T in the cabin at midnight on a randomly selected night can be modeled by a normal distribution with a mean of 8.5 and a standard deviation of 2.25. Let Y equal the temperature in the cabin at midnight on a randomly selected night in Fahrenheit. And we're going to use this formula to help us. What is the standard deviation of Y? So pretty much though the formula for what F is, or realistically what Y is, right? Y is take your Celsius temperature times by 9.5 and add 32 degrees to it. But we're looking at standard deviation of Y. So adding a number doesn't affect my standard deviation. So I'm just going to be multiplying my standard deviation by that 9.5. So again, sigma of Y is going to equal 9/5. Sigma of, I guess you would say C, or whatever the original distribution is. So 9/5 times 2.25. And if I say boom, that's why I know, boom, this one's wrong and this one's wrong. No adding. I don't think the answer doesn't make sense. And so it is of the original standard deviation. All right. Number 3, imagine that we randomly select a day from the past 10 years. Let X be the recorded rainfall on the date in the airport at Orlando, Florida, and Y be the recorded rainfall on the date at Disney World. Suppose that you know the mean of X and Y and the variance. Those should be those squared. Of both variables. Can we calculate the variance of the total rainfall to be the certain our variance is sigma squared of X? That's what this is, over sigma squared of Y. Sigma squared of Y. Or sigma of Y squared is the correct way to say it. I apologize. So can we do that? The answer is no. Remember, this formula only works independent. That's the only time we can add the variances. So since these two places are so close together, you would expect how much it rains at the airport and how much it rains close to that are probably pretty dependent on each other. So the answer is no. This doesn't matter. It doesn't matter if it's discrete or continuous. That has nothing to do with it. The formula applies the same way. So it's not 1 or 2. Now we'll skip C for right now, which would be the correct answer. But no, the variances of the sums is not equal to the sum of the variances because it is not reasonable to assume that they're approximately normally distributed. Again, that doesn't matter. All we know that is if they are both approximately normal, then when you combine them, the new shape is approximately normal. No, the variance of the sum is not equal to the sum of the variances because it's not reasonable to assume that they are continuous. Again, does not matter. The formula applies both ways. So that is why it is C. It's all about they need to be independent. Number 4. So the survey of study habits and attitudes is a psychological test that measures academic motivation and study habits. The SSHA score F of a randomly selected female student at a large university has a mean of 120 and a standard deviation of 28. The M has, again, intersected male student has a mean of 105 and a standard deviation of 35. Suppose we select one male student and one female student at random from the university and give them the test. Assume that F and M are independent random variables. What is standard deviation of the difference? All right, so we know that. So we know that we can do the variance of D is equal to the variance of F plus variance of M. That's the one weird thing here is although we're subtracting these variables, you always add. Again, so variances, well, that's just standard deviation squared. So we're going to do standard deviation of D squared is equal to, well, variance or standard deviation of F is 28. So we're going to do 28 squared plus 35 squared. And then we want to find the standard deviation. So we're going to square root both sides. So 28 squared plus 35 squared. Then I'm going to take the square root of that answer. 44.822. Okay, so right off the bat, I can cross off, cross off, cross off. Oh, look at that. They're all wrong. So I don't even need to worry about the interpretation, but let's just go through it. That is my new standard deviation. Again, it says if many pairs of male and female athletes are randomly and independently selected. So that's just that idea of large numbers. These variances only work. They're not very accurate with one person, but in the long run, that's about how far they would be. And again, it's just the same regular standard deviation interpretation. The difference of their scores will typically vary by about standard deviation away from the mean. And it's important, this mean of 15 points. Remember, if we're talking about sigma of D, we need to compare it to mu of D, and that comes from mu of F minus mu of M. F was 120 minus mu of M was 105, which is why it is 15. So that is where that mean comes from as well. Alrighty, and last one. A time and motion study measures the time required for an assembly line worker to perform a repetitive task. The data shows that the time X required to bring a part from a bin to its position on an automobile chassis follows. So X is normal, mean of 11, standard deviation of 2. The time Y is normal with a mean of 20 and a standard deviation of 4. The study finds that the time required for the two steps are independent. That is our big word to allow us to combine variances. What is the shape, center, and variability of the total time required for the entire operation? So total time, right? So that means we could have this variable total is going to equal to X plus Y. The time for to bring it over and then the time to assign it. All right. They're both normal. So if you combine two normal distributions, then your answer is going to be normal. So we can cross off, not uniform, not uniform. Okay. My means are just going to add mean of 11 plus 20 equals 31. So mean of 31, mean of 31, mean of 31. None of those helped, but that's okay. I'm going to do the standard deviation down below. So again, sigma of total, I need to square that as sigma of x squared plus sigma of y squared. And then I'm going to take the square root of both sides. So standard deviation of the total is equal to the square root of sigma of x squared plus sigma y squared. To fill those numbers in, standard deviation of 2 and 4. So we got 2 squared plus 4 squared. So that is 4 plus 16, which is the square root of 20. So second square root 20 equals 4.47. So I don't think any others have 4.47. Yeah, standard deviation 36, nope, and 6, nope. So that is why it is E here. Alrighty, that is 6.2 quiz answers.